Welcome back to geometry. This video is going to cover 17.3, or the area of a sector. So our warm-up is based on what we did yesterday. Find the length of arc AB. So S is usually used for that. And we're going to do our fraction, 80 degrees out of a full 360. And that's going to be multiplied by 2 times pi times radius 6. So the fraction we could actually reduce down to 2/9. 2 times 6 is 12, so that's 12 pi. So that would be 24/9 pi. That could be reduced down to 8 pi over 3. Or if you like fractions or decimals, you should have got about 8.38 feet. All right. So we found chunks of our circumference. Now we're going to find slices of our entire area. The area of a circle is pi r squared. Now we're just going to find a fraction of it. So a sector of a circle is a portion of the circle bounded by 2 radii and their intercepted arc. It looks kind of like a slice of pizza. A sector is named using the ends of each radius and the center of the circle. You have learned how to find the area of a circle. You can use the proportional reasoning to find the area of just a sector or slice of that circle. So we got a table here. If we look at the picture, it asks what's our central angle. Well, the central angle is 90 degrees. What is that as a fraction of a circle? Well, that would be 90 out of the full 360. And then we could drop the zeros and divide by 9 and see that it's also 1/4. So the area of a whole circle is pi r squared. In this one, it's going to be pi times 10 squared, or that'll be 100 pi. 100 times the pi key. Ooh, I got a little glitch in my marker here. And 100 pi as a decimal is about 314.159. So if we want just the area of that blue sector, we're going to do 1/4 our fraction times 100 pi. 1/4 of 100 is 25, so that's 25 pies. And that would be, as a decimal, about 78.5398. In this case, they did give us units, so it'll be centimeters squared. Area is found in squared units. Second one down, our central angle, that looks like a diameter. So we've got 180 degrees. As a fraction, 180 degrees out of 360. Drop the zeros, divide by 18. That's a half of a circle. So the area of our full circle, now here they gave us the 10 centimeter radius. Here it's a 20 centimeter diameter. So it's actually going to be the same. Pi times 10 squared. So that is 100 pies. And that, as a decimal, 314.159. So the area of just the sector is going to be our fraction 1/2 times 100 pi. Half of 100 is 50. 50 pi as a decimal is about 157.08. Again, our units, centimeters squared. Okay, now we got a practice problem for you next. So if you pause the video real quick, fill in this table just like we did, and then fire it back up and see if you got them right. So here, our central angle is 60 degrees. As a fraction, that would be 60 out of a full 360. Drop the zeros, divide by 6. That's 1/6 of a circle. Our area is pi times 10 squared. That is 100 pi, or once again, 314.159. And now our sector, we're just going to take our fraction, 1/6, and multiply that by 100 pi. Decimal you found should have been about 52.3598 centimeters. All right, next one. Our central angle is 135 degrees. That would be 135 out of a full 360. That reduces down to 3/8 if you divide by 45. Top and bottom divided by 45, we get 3/8. This circle, again, has the same radius. So our area is going to be 100 pies, or about 314.159 square units. So we want to do our fraction, 3/8 times 100 pi. The decimal you found should have been about 117.81 centimeters squared. Oh, I forgot the squared up here. Area is always in squared units. All right, excellent. And this, we can now come up with our formula for the area of any sector of a circle. The area A of a sector with a central angle of x degrees of a circle with radius r is given by, once again, this part is the full area of our circle, and we're going to knock it down with the fraction of that circle. A lot like what we did yesterday with circumference. Okay, in example 2, we've got the bristles of a fan brush are the sector of a circle. Find the area of the bristles. Well, area, it has it listed in the picture as a 120-degree angle out of a full 360-degree circle. And then we're going to have pi, and then our radius that we're going to square is 3. So 3 squared is 9, 9 times pi, and then we're going to multiply that. 120 over 360 reduces down to 1/3. 1/3 of 9 is 3 pi, or approximately 9.42. Our units are here in the picture, centimeters squared. All right, example 3, we got a pizza. One part of a pizza is topped with only green peppers, and the other part is topped only with mushrooms. The part topped with mushrooms has an area of 40 pi inches squared. What is the radius of the pizza? So here now, we're just solving for a different variable. Area of the sector is our fraction, x over 360, times the full area, pi r squared. So the area of, it says the part topped with mushrooms has an area of 40 pi. So this area is 40 pi. And the area with mushrooms is 225 degrees. 225 out of the full 360-degree circle times pi times r squared. And they asked us to find the radius. Oop, I forgot my equal sign goes right in there. So we want to get that r by itself. Well, the first thing I would do, divide both sides by pi. We got a pi here, divide it out. We got a pi here, divide it out. Okay, now this 40, I'm going to write it as 40 over 1. And I want to divide both sides by 225 over 360. And if I divide this side by 225 over 360, I would keep change flip. I would bring it up and flip it over. So now it's 360 over 225. So if I multiply my numerator times my numerator, and my denominator, 225 times 1, I'm going to get some value. And actually, if you do that right on the calculator, it's going to turn out to be a nice 64. 64 is equal to r squared. How do we get rid of the squared? We square root. We square root. The radius is equal to 8. What's our units? Inches. 8 inches. There we go. All right. Example 4. This is a little bit of a thinker too. Find each area occupied by the sprouts between the concentric circles. So here, the part we see in the picture that's green, we want that. So what we're going to do here is find, I'm going to scribble over this in red ink, If we find all of this area, and then we subtract out the area of the smaller sector in blue, what we'll be left with is just the area that those sprouts are in. So here's the big idea. We're going to take the big sector, big S, and then we're going to subtract out the small sector. And what we'll be left with is the green area where those sprouts are growing. All right, so let's start with the big sector. Area equals. Now we got to be careful here. They gave us this is 100 degrees, but that's not the sector that we're looking at. We're looking at the rest of it. So 360 minus 100 is 260. There's our fraction, 260 over 360. And then it's going to be pi times big radius is 15, so that's 15 squared. So if we punch that in our calculator, we're going to get about 162.5 pi. And if we multiply the 162.5 with the pi button, we get 510.509 centimeters squared. So that up here is the big sector, big S, 510.509. I'm going to switch to blue ink, and we're going to do the small sector. It's going to be a lot the same, only the radii will change. Area is still going to be the 260 over the 360 times pi times, now here they're trying to fool us a little bit. You know, they gave us this was 15, or this was 5, and we know the whole thing is 15, so that means this radius is going to be 10. 10 squared. So we punch that in our calculator. You would get 72.2 repeating times pi, or about 226.893. All right, so we got our components. Big slice, 510.509, minus small slice, 226.893, and we get our answer of 283.616. Our units are centimeters, and its area, so those centimeters are squared. Whew. So there's example 4. That was a juicy one. Time to pause the video and try our practice problems. Fire up the video and see if you got the same answers as I did. All right, number 1 here doesn't look too bad. Find the area of the shaded sector. Give your answer in terms of pi. So there will be pi in our final answer. For letter A, our area of our sector is the fraction 300 over 360 times pi times 9 squared. So that'll be 81 pi times our fraction. If everything turns out good, you should have got exactly 67.5 pi. Our units here are meters, and it'll be squared because we're doing area. All right, letter B looks about the same, but now our fraction is 135 over 360 pi times 12 squared. So that'd be 144 pi times our fraction. That should turn out to be 54 pi. Our units are centimeters squared. Centimeter, there we go. All right, what's number 2? Oh, number 2 is just a tiny one up here. If the angle measure of a sector is 210, what fraction of the circle is the sector? Well, let's do 210 over 360. We can immediately drop the zeros. And then when I look at that, I know that the top is divisible by 3 and the bottom is divisible by 3. So we could do that as our first reduction. 21, got a little glitch there. 21 divided by 3 is 7. 36 divided by 3 is 12. So that is 7/12. That's pretty terrible. Let me see if I can fix that. 7/12 is our fraction. All right, number 3. Find the approximate area of each sector with given measure x degrees in a circle with diameter d or radius r, round to the nearest hundredth. So in part A, our area will be, our fraction is 25 out of 360 pi times radius squared. Here they gave us the diameter is 13. Half of 13 is 6.5. So you punch that in the square the 6.5 times pi times 25, divide by 360. You should get the area is about 9.22. Our units are millimeters, and they will be squared. In letter B, our area is 73 degrees out of a full 360 times pi. Now they gave us the radius here, so that's going to be 8.2 squared. If your calculator skills are good, you should have got 33.02 feet squared. All right. Fourth problem here, it's you can just model this right off the bean sprouts one we did. Very, very similar. So let's start right off with the big circle. Our big circle, now here our arc is the one we want, that's 150. So our big circle's arc area is going to be 150 out of a full 360. And we're going to multiply that by pi. Our radius there is 6, and that'll be a 6 squared. So the area of the big one should turn out to be 15 pi, or approximately 47.1239. Oop, that's a little ugly. Let me fix that. I'm going to write it down here. 47.1239. Again, that is the big arc. So that would be all of this red area. And now we're going to subtract or cut out the smaller inside arc. So the smaller arc is going to be area equals, same 150 over 360, but now it's pi. Our radius here is only 4, so that'll be 4 squared. So that area turns into 20/3 pi, or approximately 20.944. So here's our big down at the bottom. We're going to minus out the small, 20.944, and what that leaves us is 26.18. Our units are inches, and it's area, so they're squared. Okay, what do we got here? Sundar makes a logo shown for a florist. It consists of the yellow rectangle, 2 yellow sectors on top of the rectangle to make flower petals, and 3 green sectors below. Estimate the area of the flower petals to the nearest hundredth. 1 ounce of ink can cover that many square inches. Okay, now when I first read this one, I approached it a little off. I did confer with the other geometry teachers, and they said that this part is actually not part of the logo, so we're not going to count these 3 below. So, part A, estimate the area of the flower petals to the nearest hundredth. Well, we've got 2 parts. We've got a rectangle plus 2 quarter circles. So the rectangle's easy. If I slide this down a little bit, we can see here this is 1 inch, and that would make this 1 inch. They are marked congruent. So this is a 2-inch side, and this is a 2-inch side. So the area of our rectangle here is a 2 by 2. And now we're going to add to that 2 quarter circles. So up here is our first quarter circle. Here's the other. So our fraction there is going to be 90 out of 360. And then we're going to have pi times radius squared. The radius is just 1, so that'll be 1 squared. So the 2 by 2 is 4 plus, this is going to be 90 over 360 is 1/4 pi, times 1 squared is just times 1, so that's just 1/4 pi. And we multiply 1/4 pi by 2, so that's 2/4, or pi over 2, or a half pi. 4 plus a half pi, 4 plus 1/2 pi is equal to about 5.57 inches squared. Now for part B, 1 ounce of ink in the printer can cover 625 square inches. How many times can we print the flower petals at a given size to use 1 ounce of ink? So we're going to divide that by our 5.57 inches squared. You know, each time we print it, we'd use that many. We've got that many square inches in the printer, or for 1 ounce of ink can cover that much. If we divide that, we get about 112.208. So the 0.208 doesn't matter because we're talking about how many times we can print it, 112 times. Excellent. All right, number 6, a semicircular window. So here's our semicircle window, is mounted over a rectangular entryway. The diameter of the window is 48 inches. To what nearest square inch is the area of the window? Well, area, this is a semicircle. So that is 180 degrees out of 360. And then we're going to multiply that by our pi. Now we need our radius squared. This is the diameter. So we're going to cut that in half. 24 squared times pi multiplied by a half. The area of our window, and they do want it rounded to the nearest square inch. So that's going to give us about 905 inches squared. All right, I think we got one more to go, and then this video will be over. Yeah. The spokes on the rim of a bicycle wheel are equally spaced. Each spoke is connected to the center of the wheel to the rim of the wheel. There are 24 spokes connected to the rim. What angle is formed between each spoke? Well, there's 360 degrees total. They're equally spaced, so we're going to divide that by 24, and that comes out to be a nice 15 degrees. Part B, if each spoke is 14 inches long, what is the area of the sector formed between any two consecutive spokes? So our area is going to be our fraction, 15 out of 360, times pi times the radius squared. And our spoke is 14 inches, so that's our radius, 14 squared. You punch that in your calculator, and you should get about 25.66 inches squared. Now in the last one here, suppose the area of the sector formed by two consecutive spokes is 6 pi square inches. What is the length of each spoke? So if we come back up to what we did here in part B, we're just going to change this area here to 6 pi. 6 pi is equal to the same fraction, 15 over 360, and we're going to multiply that by pi times our new radius squared, because we're trying to find the length of each spoke, which would be the radius. So we want to get r by itself. Well, we can very quickly begin by dividing both sides by pi, so that's gone. That's gone. Now I'm going to divide 6 by 15 over 360, or we could multiply by the reciprocal, 360 over 15. And that's going to equal r squared. So if we work that out, we're going to get r squared equals 144. And that's perfect because if we square root the left side, we'll get r equals. If we square root the right side, we'll get 12. Now the spokes are 12 inches long. All right, that's the end of the problems. That's the end of the video. I will see you in class.